Colby, 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 math.com.
Today we started looking at simple probability of simple events, and also sample spaces. Sample spaces, which you can define by looking at a tree diagram of different choices, will tell you all of the things that are possible, and we're going to explore more tomorrow why that's important when calculating probability. In order to know what's probable, you first need to know what's possible. Problem number 1 says, when Goldilocks visits the home of the 3 bears, she can choose to eat from Papa Bear's bowl, Mama Bear's bowl, or Baby Bear's bowl. She can also choose to eat her porridge plain, or with strawberries on top, or with blueberries on top. Create a tree diagram to determine how many different ways Goldilocks can eat her porridge, and how many ways did you find. So the first choice Goldilocks has is which bowl to eat from. And she can eat from Papa's bowl, Mama's bowl, or Baby's bowl. If she chooses to eat from Papa's bowl, she has 3 choices for toppings. Because even though plain means no topping, that's still a choice. She can have it with no toppings, in other words plain, or with strawberries on top, or with blueberries on top. Likewise, if she eats from Mama Bear's bowl, she has those same 3 choices of toppings, either plain, strawberries, or blueberries. And if she eats from Baby Bear's bowl, she can have it plain, or with strawberries, or with blueberries. So the sample space, the set of all possible choices or outcomes, would be Papa Bear's bowl plain, or Papa Bear's bowl with strawberries, or Papa Bear's bowl with blueberries. Or she could eat from Mama Bear's bowl and eat it plain, or Mama Bear's bowl with strawberries, or Mama Bear's bowl with blueberries, or Baby Bear's bowl and eat the porridge plain, or Baby Bear's bowl with strawberries, or Baby Bear's bowl with blueberries. So we see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ways that she can eat the porridge. But we could have determined that much more easily by using the fundamental counting principle, which tells you to take the number of choices. In other words, the number of choices for bowls would be 3. She has 3 bowls to choose from. And then you take the number of choices for toppings, which is also 3, and you multiply those together to get the total of 9 possible choices. I also want to do problem number 6 with you. 6 says there are 8 marbles in a bag. These include red, blue, and green marbles. The probability of drawing a red marble is equal to the probability of drawing a green marble. There are more red marbles than blue marbles in the bag. How many marbles of each color are in the bag? I'm going to recommend you use a table for this. Red, green, blue. And let's make another column that says total. Well, the total will always be 8. That's been given to us. But try different numbers of red and green and blue marbles, keeping in mind the extra information that's given to you in the problem until you find a combination that will work. Do that during the pause and then come back and see how you did.
Paused.
The problem tells us that the probability of drawing a red marble is equal to the probability of drawing a green marble. Without even knowing how many there are, the probability of red, if it's equal to the probability of green, they're both some number of 8s. I don't know how many 8s, but if they're equal, then these numerators must be the same. They must have the same number of marbles. If it's equally likely to draw red as a green, then the number of red must equal the number of green. The other clue that's given is that there are more red marbles than blue marbles. So red is also greater than blue. And since red is equal to green, green is greater than blue. So because the total is so small, there aren't that many choices. I mean, if red has to equal green, let's just imagine we had 1 red and 1 green. Well, that's 2 marbles so far. That would mean we would have 6 blue marbles. But that would make this part false. So this isn't a possibility. if we had 2 red and 2 green, but we're supposed to have 8 marbles total, that would mean 4 blue, and again, red would not be greater than blue. If, however, we had 3 red and 3 green, that would be 6, leaving us with 2 blue marbles, and then this would be, all of these would be satisfied. Red equals green, red is greater than blue, and green is greater than blue. Just to show that that has to be the solution. If we had 4 red and 4 green, that would be 0 blue, which you might imagine could be a possibility, except the problem states that there are 8 marbles and they include red, blue, and green. That implies that there are some blue. And so this is the only real possibility. So red equals 3, green equals 3, and blue equals 2. Okay, I hope that helped with the assignment. I'll see you tomorrow.